Good morning, everyone. Today, our team members Archana, Mehala, Monik Rufina, Harika, and myself, Pooja, are going to present a modern and innovative solution in the banking sector, a blockchain based check verification and clearance system. So let's begin by identifying the problem. Traditional check clearances systems are slow, manual, and are often vulnerable to fraud. It typically takes 2 to 3 days for checks to get processed. But blockchain technologies addresses these issues by offering a decentralized and secure way to record and verify check transactions. With smart contracts, we can actually automate the entire process, that is from validation to fund transfer, which significantly reduces processing time. And also, digital checks can be tokenized and tracked in real time on a blockchain, which ensures tamper proof and transparent transactions. And some advanced frameworks even use machine learning to detect earlier fraud activities. And overall, blockchain based systems bring down the clearance time to under 2 seconds with better accuracy and security. Now, let's understand why this application is important. First, it eliminates delays and inefficiencies in traditional check clearances systems. And using smart contracts, verification and settlement can be done instantly and automatically too. Blockchain uses cryptographic features like digital signatures and hashing, which ensures that whether records are permanent. And also, by reducing the dependencies on third parties, we can speed up the process of verifying the checks and making them processed easier. And also, we can prevent major financial damages. And with the support of machine learning, we can detect uh, fraudulent activities earlier. So this also builds trust among the customers and make them move towards this innovative idea. And finally, this approach reduces human intervention and operational cost, making banking more efficient and secure.
Let's begin with a review of some prominent research studies that have explored blockchain applications in check processing. The work by N. Tejasri proposed a hybrid system using Ethereum smart contracts and QR codes for check verification and clearance. Their model ensures tamper-proof records and real-time status tracker. However, they faced challenges such as high Ethereum gas fees, technical complexity when integrating with banking systems, and low adoption due to lack of awareness or internet dependency. On the other hand, B.K. Sharma took a more theoretical route by conceptualizing check processing as tokenized digital assets. While it introduces important ideas like proof of work and proof of stake, their model lacks concrete implementation, test results, or architectural diagrams, making it suitable for background research rather than practical use. And here we have a third research paper in novel digital check clearance and secure verification based on blockchain technology. It proposes checkmate system, combines blockchain plus fraud detection, and implements OTP verification and mobile check scanning. And it clears checks under 5 minutes and detects check fraud using image processing, supports both paper and digital checks, and it also challenges Ethereum public blockchain may face slowness and privacy issues, requires all participating banks to connect to a common blockchain network. It only supports English language currently. And the fourth research paper is blockchain-powered verification mechanism for clearance systems, which adopted methodology is hybrid digital or physical check deposit and minor incentive model with security via cryptographic hashing, QR code, and multi-factor authentication. And the features are real-time transaction tracking with tamper-proof audit logs, email notifications, and secure identity management support for miners and incentive mechanisms. And the challenges are requires significant infrastructure change for banks and demands high blockchain and smart contract expertise. And the fifth research paper is secure check processing system using blockchain. And the adopted methodology is smart contracts handling verification, clearance, and fund transfer. uses cryptographic hash and digital signature for tamper-proof processing, and the features are real-time settlement with digital signature authentication, and eliminates intermediaries and central clearing houses. And the challenges are complex implementation for integration with existing infrastructure, requires agreement and participation from all banks in the permission blockchain, and does not account for damaged or multi-format physical checks. And the last sixth research paper is blockchain-based check verification and clearance system. It integrates blockchain with industrial Internet of Things for check verification in small factories, real-time detection of suspicious users based on behavioral analysis, and a federated learning model called Block Hunter speeds up check clearance and reduces reliance on intermediaries. And the challenges are implementation requires all stakeholders, banks, users to adopt the blockchain system.
So these are a summary of gaps we identified in literature study. Static signature verification. Most banks still rely on static image comparison, meaning they match scanned images of signatures. But these methods ignore behavioral details like stroke pressure or writing speed, which makes them easy to fool by skilled forgers. Fraud and tampering risk. Without cryptographic protections or immutable logs, check data can be altered, making the process vulnerable to fraud. Weak check image validation. These systems use basic image matching techniques, not advanced forensics or machine learning, limiting their accuracy. Missing multi entity consensus. Validation is done by a central clearinghouse, so there is no decentralized or distribution verification, which can introduce single points of failure. So these challenges show why we need a better, smarter system. That leads us to the core problem. To address these issues, our problem statement is blockchain enabled dynamic signature verification for secure check authentication. We aim to capture not just the shape of the signature but how it's written using behavioral traits like speed, pressure, and stroke order. We store and verify check data using smart contracts on the blockchain. This makes the data tamper proof and transparent, reducing the risk of fraud. So, how do we plan to achieve this? That's where our objective comes in. We want to build a system that captures and uses dynamic behavioral traits like pressure, stroke, speed, and order. By going beyond static image comparison, we aim to detect even expert level forgeries that fool conventional systems. We use tablets or phones to collect the behavioral data, making it accessible and easy to use. We'll train models like SVM to classify genuine versus forgery signatures. The system should not just be accurate, but also user friendly for both banks and customers. Finally, we'll integrate all this into a blockchain based check processing platform to make the entire transaction secure, transparent, and tamper proof. Together, these objectives help us move from outdated static systems to an intelligent, decentralized, and secure check authentication solution.
This is the existing model based on a base paper. This flowchart describes an automated system for verifying a check using its signature. The process begins when a user uploads a scanned image of a check. The system then focuses on the signature region. It processes this area by converting it to a grayscale, binarizing it, that is making it black and white, and then creating a skeletonized version, a thin line representation of the signature. This simplified signature is then compared with a stored pre-verified signature template to check for a match. If the signature doesn't match, the system rejects the check and notifies both the bank and the user. If the signature is a match, the process then continues. The system then triggers a smart OCR, optical character recognition, to extract key data from the check, such as the check number, and stores this information along with a verification status. Next, it generates a QR code containing the check status and other details. Finally, this QR code is embedded onto a verified digital version of the check. The bank and the user are then notified with this verified digital check and the new QR code. This completes the automated verification process. This is the proposed model diagram we are going to work with. This flowchart outlines a system for dynamic signature verification for a digital check. It's different from verifying a scanned image because it analyzes how the signature is created, not just how it looks. First, the user signs the check using a stylus or touchscreen in a mobile app. The system captures dynamic data from this process, including the stroke speed, pen direction, and how the pen pressure changes. This raw data is then pre-processed to remove noise and normalize it by resizing and aligning it, making it ready for analysis. Next, the system extracts features from this normalized data. It looks at things like the timing and flow of the signature, as well as geometric features to create a detailed profile of the user's signing style. This profile is then fed into an ML model like LSTM, long short term memory, for verification. This model compares the newly captured signature's dynamic features against the user's stored signature profile. If a match is found, this system creates a smart contract record and a signature hash. The check data and this signature hash are then stored on a blockchain, creating a tamper-proof and transparent record. If there is no match, the system flags the signature as suspicious and alerts the bank and the user. Finally, once the process is complete, the bank and user are notified. So some of the technologies to be used are dynamic signature verification. The traditional signature scanning methods only compare the images which can be easily forged. In contrast, the dynamic signature verification captures the behavioral features of a user's signature using a stylus or touchscreen. These include the pressure, speed, stroke direction, and timing. By analyzing these factors, we can determine whether a signature is genuine or fraudulent. The second technology is the database and security mechanisms. Once the user's data and signatures are captured, they're securely stored using the databases like the PostgreSQL. Before storing, we hash the signature using the SHA-256, a secure cryptographic algorithm ensuring the data cannot be tampered. We also use the JWT tokens for secure user authentication. The third technology is the blockchain integration. The backbone of our system is the Ethereum blockchain deployed on a private network. Here we store the transaction records immutably. Once a check is verified, it is returned to the blockchain and cannot be changed or deleted, which drastically reduces the possibility of fraud. We also use the smart contracts to automate the clearance process. The fourth technology is the real-time notification system. To enhance the user interaction, we have added the Twilio API or Firebase cloud messaging for notification purposes. These are used for sending one-time passwords, check status updates, and fraud alerts, keeping the users informed at all stages of their check processing. The last technology is machine learning and AI. Finally, our system leverages the machine learning to boost the accuracy of signature verification and fraud detection. We use the algorithms like LSTM, SVM, random forest, and convolution neural networks, implemented through libraries like TensorFlow, Keras, and Scikit-learn. Conclusion. To conclude, our system combines the strengths of the dynamic biometric input, secure databases, immutable blockchain, automated smart contracts, real-time messaging, and AI-based verification. This multi-technology approach ensures that check transactions are faster, with greater trust, less fraud, and improved. So here are some of the references we have used in our project. Thank you.